Hey guys, in this video I'm going to be going over recognizability in a radiographic image, which is chapter 14 in our digital age physics book. First things first is, recognizability and visibility are two different things. Do not get them mixed up. Now I want you to think of a car analogy. You can see a car coming down the road, which would be, you can visualize it. You can visually see it, but you might not be able to recognize it. You might not be able to recognize if it's a Toyota or if it's your mom's car, something like that. Just think, that's how you can decipher between those two. But also, you have to have visibility and recognizability in an image. But if you only have visibility and you do not have recognizability, I don't know why those are parted so far, they're supposed to be together. But if you only have visibility and you don't have recognizability, then that image, you might as well just throw it in the trash because you can't recognize what's going on in the image. And that is not good. Our geometrical factors are what directly affect our recognizability of it in an image. Now, recognizability is basically the same thing as geometrical integrity. Recognizability goes off of three factors. And I'm going to space this out like I did in the other video so you can see what's going on. Now, you are going to want, and it goes off of three factors, and that is spatial resolution, magnification, and shape distortion. Now, spatial resolution, we're going to want the maximum amount of that, because spatial resolution is also known as our image detail sharpness, which was named by the ARRT. They are the ones that named that, I guess, basically. And now we're going to go to magnification. Now, let it be known that you're automatically going to have magnification in an image. And magnification is directly affected by OID. OID is what causes your magnification. And that is why we try to keep our OID at a minimum amount that we can. But you are going to have magnification. Now, magnification is also known as size distortion. And we want to keep this at a minimum. But, no, I'm sorry. I'm so sorry. I thought I was on shape distortion. We want to keep this at a optimum level. And like we said in the last video, that is your sweet spot. It's like that middle. You don't want too much, you don't want too little. And also, magnification isn't always good. We don't love it, but it's something that we have to deal with. But we can also use magnification to our advantage, such as when you have a small body part that you are needing to be able to see on an image, to visualize and recognize on an image, we can use magnification to our favor. Now, shape distortion. Now, shape distortion, think of it as like this. Anytime you have an angle on the beam or tube, you're going to have shape distortion. And that is where it directly affects the shape. Now, what I was saying is you have a ball and you have the tube. We're going to put an angle on the tube and say it's coming from over here. This is our tube. Whenever you do that, that image is going to come out like this. It's going to come out a different shape. And that's how you could think of shape distortion. Shape distortion affects the shape. Magnification affects the size. Now, I also want you to remember that magnification is, let me make these lines a little bit longer. Magnification is a true representation of your object. It is just larger. It just makes it larger. Now, the way I want you to think about that is if I have a magnifying glass up to some words on my physics book, those words are still the same exact words that if I was to take away the magnifying glass, it'd be the same words. They're just larger. But in shape distortion, it is not a true representation, because it is changing the whole shape of that anatomy. It's not at all a true representation. Now, in another video, I went in to tell about how you could find magnification factors, and you could do the magnification formula and the percentage of magnification in an image. So I'm not going to go back over that. You can go look that up. But I also want to go over Penumbra and Umbra. So, Penumbra is bad. And we know that to be as our blur in an image. And also it is defined, penumbra is defined as is about the outside edges. And it's going to get worse the farther away you get from the CR, because you got to think about it, that CR is usually, if there's no angle on the tube, going to be perpendicular down to that part. And when it is perpendicular to that part, that means that all them electrons are going to be focused right there. And remember from other chapters, we learned that at the CR, that is where or at that anatomy where the CR is perpendicular to, that is where you're going to get your best shape spatial resolution, which we also know is also known as image detail. So the farther you get away from the CR is the worse the penumbra is going to get. Now we know umbra is good. And that is your inside edges of the anatomy and the image. Now, that is where I'm going to end today. If you have any questions, just put them underneath in the comments, and maybe I can try to help you out.